Welcome to Day 13, Reciprocals and Equations. You will need the 3 P's, pencil, paper, and patience. You will also need a graphing calculator. Today, we will look back on an old topic and add it to our knowledge in solving equations. When dealing with reciprocals and equations, there are 3 situations that you should recognize. First, remember that reciprocal functions can be rewritten as the flip value of their corresponding trig function. So one technique we can look to use is finding the reciprocal of the given trig function and taking the flip value of it. Another technique we can use is conversion, usually of tangent or cotangent into terms of sine theta and cosine theta. We remember that tangent theta can be rewritten as sine theta over cosine theta and cotangent theta as cosine theta over sine theta. Finally, remember that all of our reciprocal functions can be rewritten as the reciprocal of their corresponding functions, such as cosecant of theta equal to 1 over sine of theta. So sometimes it might be helpful to rewrite them as a fractional value. Now let's look at some examples. In example 1, we are asked to solve for the exact value of x. Remember that our end goal is to find all values for x which will satisfy the equation. Because this problem is a simple expression, we can utilize the reciprocal. Recall that secant of x is equal to 1 over cosine of x. In other words, secant of x has the flipped value of cosine of x. This means that I can rewrite this problem as cosine of x equal to negative 1/2. I note my value is negative, which means my angle values for x will be in quadrants 2 and quadrant 3. And from my chart, I should know that cosine of theta will equal 1/2 when the angle is 60 degrees. So now I know my reference angle is 60 degrees. I can use the reference angle to solve for the values of x using quadrant operations. I should get x in 2 equal to 120 degrees and x in 3 equal to 240 degrees. In example 2, I have 2 different functions of theta. In this case, I know since I have tangent theta, I can probably use conversion to solve. So, I will convert tangent theta to sine theta over cosine theta on the left and place my sine theta over 1 on the right. Now, in order to solve, I will need to cross multiply. On the left, I will have sine of theta, and on the right, I will have sine of theta times the cosine of theta, or cosine theta times the sine of theta. Either way is fine. Now remember, our goal here is to set the equation equal to 0. Many of you at this point will be tempted to divide out a sine theta. Don't do it. Instead, subtract a sine theta from both sides to set the equation equal to 0. We do this not only to solve, but to preserve half of our solutions that we would have lost had we divided out. Once I am set to 0, I can factor a sine theta out of my right side and rewrite the product of sine theta and cosine theta minus 1. I set vectors equal to 0 and proceed to solve in the same manner I did in previous days. On the left, I should get a reference angle of 0 or 160 degrees, which turns out to be my angles as well, both in quadrant 1 and quadrant 2. On the right, I get a reference angle of 0 and 360 degrees, and this also turns out to be my answer. So I am left with 4 angles that, if plugged into the original equation, will give me a correct statement. In example 3, we see where rewriting a function as a fractional value of its reciprocal can be useful. Here, I notice a problem that has both cosine and secant functions involved. Since I know I can find exact values of cosine, I will choose to rewrite secant theta as an equivalent statement 1 over cosine of theta. Remember to multiply the coefficient through, and you should get 7 cosine theta plus 1 equals 6 over cosine theta. Placing our terms on the left over 1 shows us to proceed. We need to multiply all the terms by a common denominator, in this case cosine of theta. I multiply both sides by the cosine theta, remembering to distribute to both terms on the left side. If I have distributed correctly, I should come out to 7 cosine of theta squared plus cosine of theta equal to 6. Some of you are saying, well, where did the 6 come from? Well, the cosine of thetas cancel each other out when you multiply through. Now I'm going to subtract that 6 from both sides, so I can set my equation equal to 0, and now I'm ready to factor. If you like, you could use funky factoring or quadratic equation at this point. I'm going to use funky factoring. Both should give you the same factors. I'm going to draw my parentheses, place a 7 cosine theta on the left. I multiply my a and c to get negative 42. The factors that add up to b are 7 and negative 6. Now I'm going to divide out any common factors. In the first there's 7, so that's gone. And I come out with two factors, cosine of theta plus 1 and 7 cosine of theta minus 6. I set both factors equal to 0. And now I solve for my reference angles. On the left, I get a reference angle of 180 degrees, which is also my theta in 3. On the right, I should get cosine theta equal to 6 over 7. To review, I find the value of the reference angle by taking the inverse cosine of both sides and getting a value equal to about 31 degrees. Since cosine is positive, I know the two angles I want are in quadrant 1 and 2, and I use quadrant operations with the value of the reference angle to get the values of theta as shown. So here are the things you should be able to do. If you're having trouble with any of these skills, go back, rewatch the video, and focus on the skill you're struggling with. Till next time, this is Mr. Mackman signing off.